Today I'm going to be talking about using the fundamental theorem of algebra, and this is the first day of Chapter 5, Section 6. So what the fundamental theorem of algebra says, that if you look at the highest degree of the polynomial function, that's how many zeros you will have. So for number 1, the highest degree of the polynomial function is 3, so you will be getting 3 zeros. For number 2, the highest degree is 4, so you'll get 4 zeros. And number 3, the highest degree is 12, so you'll be getting 12 zeros. Also, these zeros can include positive numbers, negative numbers, and also imaginary numbers. So we're going to think about that while we do these. All right, so once again, we're finding all the zeros of the polynomial function. So if I put this in the calculator, I look for my whole number values that hit the x-axis, and for this one I found 1 and 2 were going to work for me. So I'm going to test it using synthetic division. So I'm going to test 1 first, and I'm going to use 1, 5, -7, -29, and 30. So we're going to test to see if this works. Bring down the 1. That's 6, 6, -1, -1, -30, -30. So this one checks out. That one works. So let's try 2. Bring down the 1, 2, 8, 16, 15, 30. So that works as well. So what we can do is, since we started at x to the 4th, we divide it, it's x cubed, then x squared. So we can write this as x squared plus 8x plus 15. I can factor this out quite easily. So this is x plus 3 and x plus 5. So my solutions to this are 1, 2, -3, and -5. And we did it with 2 layers of synthetic division. All right, let's do another one of those so you can see how that's done again. So I looked and I found that 2 and -2 cross my x-axis, so we're going to use those two to test. So let's try 2. So we have 1, 5, -4, -20. That's going to be 7, 14, 10, 20, 0. So that one works out, and we can try at -2. It's 5, that's -10, that's 0. Since we started with the x third, that's x squared. Now our last one is linear, so that's x plus 5. So our solutions are going to be 2, -2, and -5. So you can do more than one layer of synthetic division. Right, we have another one, and this is x to the 5th. So I noticed that -5, 1, and 4 all crossed our x-axis, so we're going to test those using synthetic division. So we're going to try -5 first. And we have 1 is 0 for the placeholder x to the 4th, -20, 20, -21, and 20. So we're going to use those. Bring that down, -5, -5, 25, 5, -25, -5, 25, 4, and -20. This one works out. So let's test out 1. So we have a -4, we have a 1, -4, -4, 0. That one tests out. We can do a third layer of synthetic division, which is 4, which is going to work as well. Now, what we have left over is we went from x to the 5th, x to the 4th, x to the 3rd, and now we're at x squared plus 1. And we're going to set it equal to 0 to find our other zeros. Since we have an x to the 5th, we've only found 3 zeros. So that means we have 2 more left. So we can solve this by subtracting 1, square root, plus or minus. So we have x equals plus or minus the square root of negative 1. And the square root of negative 1 is I. So our answers are negative 5, 1, 4, and plus or minus I. So those are our 5 answers, including an imaginary one. All right, next up, we can actually determine the number of imaginary zeros for the function with the given degree and graph. So I give you that the degree is 5, okay? And if we look at the function, it only has one intercept that we can see, only one real number. So the number of imaginary zeros are going to be 4. And that's our answer.